This is an example of automotive brakes, how it works. So it says that the caliper cylinder requires 1200 psi to stop a vehicle. Now this is the schematic. So this is the brake lever. Driver applies force here at the brake lever, and then that is multiplied by this brake booster, and then it is multiplied by the pressure is developed by the master cylinder, and then it goes to the brake cylinder, which is a little bit bigger than the master cylinder. So about now it says that it needs 1200 psi on here. However, this brake booster develop about 500 psi. So this master cylinder only has to develop 700 psi. So that is the force by this piston is calculated from this 700 psi. So if we want to calculate the cylinder force that is required to produce that 700 psi, force is pressure times the area. So 700 psi times the area, which is pi by 4 d square. The area, the diameter of the master cylinder piston is given 0.75. You can check that as going back to the video. So I have calculated that's 309 pounds force needed to develop that 700 psi. So that's 309 pounds. Now to solve any lever problem, we'll have to take the moments with respect to the pivot point. So moment with respect to the pivot, anti-clockwise moment, all moments sum to 0. So to do that, in this case, we can resolve this force. So let me extend this. So we can resolve this force horizontally. This is 30 degree. So that force will be F cosine 30 degree. And then the downwards force, this will be F sine 30 degree. Now let's take the moment. So with respect to the pivot point, this cosine 30, so we are fixing it right here. Cosine 30 will make a counterclockwise moment, which is positive F cosine 30 degree times the distance. So that is from 1 inch and 7 inch, about 8 inch away from that pivot point, plus this force due to the sine 30, which will also make a counterclockwise moment with respect to the pivot. So that's plus F sine 30 degree times that is 2.5 inch away from that pivot point. Now we have this cylinder force, which will do a clockwise moment like that. So 309 times 1 inch, and everything summed to 0. If I solve for F, I calculated 37.8 or so. Check this calculation. I think I recall last year people got 30 pounds or something. I can't remember. So that's what I got, 37. Now it says what kind of lever system is this? Now I think almost half of the class make a mistake of this lever system. This is a second class lever. Force is multiplied by this lever system. So if you look at the book equations and try to use them directly, some of you might think this is a third class lever, which is ridiculous. There is no reason this thing to be third class, because the driver force should be as minimum as possible. He is stopping a vehicle, or she is stopping that big vehicle, which requires probably the brake force somewhere around 3,000, 4,000 pounds on the brake rotors. So this is a second class lever. Anyway, for solving cylinder problems, do not use that direct equations in the book. It is much easier to take the moment with respect to the pivot point than to figure out which lever is that and all these distance and dimensions. I hope that helps.